Why is it that all prime numbers greater than 3 are of the form 6n-1 or 6n+1, where n is a natural number? Why are they all of this form? So let's consider a sequence of numbers. Here we'll go 9, 10, 11, 12 through 28. And let's think about every other number. So like every second number is divisible by 2. For example, 10, 12, 14, 16, 18, etc. These are all divisible by 2. So we know that those cannot be prime numbers. But then every third number is divisible by 3. For example, 9, 12, 15, 18, etc. are divisible by 3. So we have to look for places, numbers that is, that are not visible by 2 or 3. So where do they occur? So let's take a look at, notice where the gaps are. There's a gap here. This is not divisible by 2 or 3, this here. And where it's these gaps occur are going to be just before 2 or 3 or just after 2 or 3. So let's actually circle those. So let's see where 2 and 3 come together. So 2 and 3 come together at 12, 18, 24. And so there's a gap just before 12, for example, and just after 12. Just before 18, just after 18. Before 23, excuse me, just before 24 and just after 24. So these are places at which we could have candidates for prime numbers. And so what kind of, notice here though, so if something is divisible by 2 and 3, if we multiply these together, any number divisible by 2 and 3 is also divisible by 6, right? Because if 2 and 3 both divide into 12, then so does 6. If 2 and 3 both divide into 18, then so does 6. If 2 and 3 divide into 24, so does 6. So we want to go just before any number that's divisible by 6 or just after any number divisible by 6. Of course, if something is divisible by 6, that means it's going to be of the form 6n, where n is a natural number. So we want to find candidates for our prime numbers. Therefore, we're going to be at the spot just before 6n and just after 6n. Just before 6n, just after 6n. That would be at 6n-1 and 6n+1 over here. 6n-1, 6n+1 over here. 6n-1, 6n+1 over here. Now let's see, if we check those numbers, do we have primes? And actually, if we check over here, 6n-1, 11 is a prime. Over here, 13 is a prime. Let's check these over here. Here's 17's prime, 19's prime. How about over here? 23 is a prime, but 25 is not a prime. Because 25, even though it's not divisible by 2 or 3, it is divisible by 5. So that leads to the observation that a necessary condition for number greater than 3 to be a prime is that it is of the form 6n-1 or 6n+1, where n is a natural number. But this is not a sufficient condition. So it's necessary, but not sufficient to have a prime number. As we saw in the previous slide, 25 is of the form 6n+1, but it's not prime. Now, one other thing to note is I've stated this is 6n+1 and 6n-1, but actually the 6n-1 can be expressed as, say, 6n+5. So, for example, 6n minus 1 is the same as 6n plus 5, where n is a natural number. For example, 17 can be expressed as 6n minus 1. It would be 6 times 3 minus 1. That's going to give you 17. Or it can be expressed as 6 times 2 plus 5. That'll also give you 17. So sometimes when you see the characteristics of primes, it'll be said as 6n plus 1 or 6n minus 1, or they might instead say 6n plus 1 or 6n plus 5. So that leads to another way to show that the primes have to be in that particular form. For example, let's take a look at the in-between numbers. Again, we know that 6 times n can't be a prime like we showed before, because obviously this is a multiple of 2 and 3. And then we said 6n plus 1 is a candidate. So how about 6n plus 2? Well, actually, you can factor out a 2 of something of the form 6n plus 2, and you get 2 times 3n plus 1. So this can't be prime. How about something of the form 6n plus 3? Well, you can factor a 3 out of that. And that's, so that can't be a prime, because that can be expressed as 3 times 2n plus 1. How about 6n plus 4? Well, there you can factor out a 2 again. So you have 3n plus 2. And finally, as we said, something in the form 6n plus 5 is a candidate, because you can't factor a 2 or a 3 out of that. So again, numbers of the form 6n plus 1 or 6n minus 1, which can also be expressed as 6n plus 5, are the only candidates for prime numbers greater than 3.